Okay, good afternoon. My name is John Berg. I am the founder of a company called ACETA. We are located in Council Bluffs, Iowa, which is right on the Missouri River across from Omaha, Nebraska. And this is our facility. It's about 65,000 square feet. And we've been doing robotic integration since April of 1983. So about almost 35 years. So we believe strongly in exploiting technology and not labor, and or people, I guess is a better word. And that, and our friend Missy Rogers of Noble Plastics, she agrees. So we've got some customers here that'll talk a little bit about how they've used robots in their facilities.
You have to want to do this. Yeah. The person that gets in charge has to want to do robotics. I now run 3 machines at one time. It's definitely made me more efficient.
When they first talked about getting a robot, I really wasn't too sure about it. Basically, go walk over there, run the machine, and let it do its thing.
You know, the nice thing about running the robot too with employees is that you're not just a machine operator anymore. You become a cell operator, a guy that's responsible for making the robot work. So the operator is not just a guy banging out parts anymore. He's a guy that's monitoring the whole system. And a lot of times he can think about what's going on next. It has really helped my shop in gross production output. We had a 60% increase in our gross output. 60% more gross output. That just talks for itself.
We have automated because it's the only way to go. It's the only way to be productive, competitive. Biggest thing is competitive, because you're beating yourself against other people who are doing the same part or could do the same part.
We struggle to find talent sometimes, and when we get busy, we can't get products out the door. The reason we looked into robotics is because of safety and ergonomic issues. Our parts are large, our parts are heavy, and putting the robot to work saves our people strains and injuries.
Automation has helped us as far as employee skills. They've learned a new skill trait. And it's also helped us be competitive. We're more efficient, we're able to produce more.
Automation's definitely made us look at the forward processes so that we have things set up differently, a little more precise, a little more front-end work to make the robot perform better. Automation's made us more competitive. When we have the robot running, it's running by itself. We're able to produce more in the same time frame that we were able to do just, a year ago today.
So there you have it. Get faster, safer, better. Obviously, lots of people have installed robots in their facilities, and they're using them for all kinds of applications. If you want to see more about applications, this screen right over here has got multiple. So after the presentation, or if you're bored during the presentation, please help yourselves. But we're here today to talk about a few things, understanding some of the benefits of robots, dissecting your need, how your company might go about, what our suggestions are for how to implement a robotic system automatically, and then quite frankly some challenge that we'd like to lay out to you as you think about the use of robotic technology in your operation. So first, there's just been an awful lot of myths generated over the years about robotics, that they're too hard to use, that they are only for high production jobs, that they are obsolete if part changes in the future, They're hard to program and maintain, and of course many people, a lot written in the press about how robots are stealing American jobs, and to be totally honest with you, at least on the last one, nothing could be further from the truth. In fact, I would tell you that our customers cannot find enough qualified labor. And so that is the biggest reason that they're actually thinking about automation, so that they can take those skilled people they already have and apply them across a much broader use of, or much broader group of machines, etc., than having to have them stand in front of a machine and just be literally do something that a robot could do as well or more efficient. So we're going to talk about these more as we go through. So one of the questions is always is how will I ever justify? How will I ever get a return on investment? And as it says here, very consistently our customers have asked us to provide them a 2-year payback on the investment. And when you think about that, who of us, if we had some money to invest, would not invest it assuming we could get 100% of our money back in 2 years, and everything after that would be money in our pocket and stuff. It's quite frankly a little amazing to me that lots of times companies look for this kind of a return. When you think about, not only does it help them from a use of their capital, but it also helps them be a more efficient company. And but it does seem to be kind of a criteria level, and that is they want a 2-year payback or less. And in many cases, there's opportunities to operate the automated cell in a unmanned or no operators in the facility. Some people call it lights out, etc. And we have a lot of customers that do that as well. So let's talk a little bit about what your company needs, or what are the many customers' needs. So lots of times they need more volume. They have equipment today. It's potentially not producing at the level that they would like it to. They can only find operators to run it maybe 2 shifts. They'd really like to run it more of a, on a 3rd shift basis. They'd just like to utilize their machine tool a little bit better. In many cases, we walk into a customer's facility and we'll say to them, what kind of machine utilization are you getting? And they'll tell us, oh, we get 80%. Our machines are running 80% of the time. And we can almost, to a person, say, that's really not true. You're actually on a manually operated machine, commonly 60% or less. And lots of times they don't believe us, but when we walk out on the shop floor and start walking through, we find out that our number is a lot closer to what they're at than their number is. And so, but a lot of people also are under pressure to lower their part costs, and they want to have better quality, and they really need to expand their workforce, so they need to better utilize the people they got. And then ultimately, there's almost nothing that drives people more than worker safety. If you've got applications that are dirty or handling a lot of weight or repetitive motion, or that's one of the areas which seem to get a lot of attention in our customers' facilities. So a little bit about comparison. So on the left here, you see watch, this gentleman is doing the same job that the robot's doing on the right manually. So he picks up this rather large sheet of metal, not particularly heavy, but hard to handle. He takes it over, and as you can see, he's much faster than the robot. So he can actually do the process in less time, but he has to stand there and do it all day long. And he can start out and go like, bang, 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 but by after lunch, and especially later into his shift, he starts to get pretty tired. And so the numbers speak for themselves. He gets about 7 hours of production out of an 8-hour day. he has a cycle time of about 60 seconds. But unfortunately, he's only getting about 60% efficiency over the whole day. And so his throughput is 250 units a day. On the other side, the robot gets to work the full 8 hours. Its cycle time is higher. In fact, it's 30% higher than the operator was, but it's 95% efficient, and it can produce 340 parts a day very consistently, shift after shift. And in many cases, this is a prime example of where they could go home and the robot, if they have the material there, could maybe run at least a few hours into the next shift. So 450 parts more per week, almost a 40% increase in production. So what do these improvements in productivity provide? Obviously, additional revenue from the machines, increased sales due to the fact they can have fast turnarounds, improved cash flow, lowering the cost due to less work in process, and their personnel are utilized for things that, quite frankly, we are years, if not decades, from automating. The other thing that is quite common, especially in the machining industry, is quality. And tolerances, most of our customers find that their part tolerances are going down and down. What used to be kind of a standard plus or minus 1,000ths or plus or minus 2,000ths in some applications, those can be done very readily without even having a closed loop gauging system. So holding those kinds of tolerances over a run of parts is very commonly done. However, many of our customers are getting much tighter tolerances, as it says here, down in the 4/10 range or 10 microns, or even down to the 3 micron range. And our customers that are doing that are on a consistent basis. They are using some kind of a feedback system, sometimes in machine process or in machine gauging, although for those types of tolerances, most of our customers just don't feel that secure being able to hold those tolerances. But using an external device like maybe a coordinate measuring machine, they're able to hold those tolerances, and they would even respond that it is almost impossible for an operator to hold those tolerances manually, because even if they can gauge them manually or very close, they'll make the wrong decision, bump the offset the wrong way, and all of a sudden they're out of their tolerance band, and it takes them quite a bit of time to get back to those kinds. So where the gauge, you can write those algorithms, and it will produce those kinds of tolerances over long periods of time. And we talked a little bit about this, but the skills gap, you can read about it in the papers. All of the trade magazines talk about it. Right today, we easily have an estimated 600,000 unfilled jobs in manufacturing, and that number is expected to grow. In fact, it's estimated that the average person working in many of our customers' shops is 56 years old. And they're only 5 to 15 years from retirement. I made the example yesterday that Caterpillar between 2012 and 2020 loses half of their workforce to retirement. So imagine a company like Caterpillar that is going to see half of their workforce walk out the door. Not only is that a tremendous skills drain, but it's tribal knowledge, it's all those things they know about making Caterpillar's products, and they have to try to fill those positions back with new workers. So it's quite frankly almost an impossible job. The other issue, of course, is safety, and none of us ever argue about safety. And this information is just about operating a press brake. So for this period of time, there were 390 some accidents. There were unfortunately 60 amputations running these press brakes. And 325 out of the 390 accidents caused more than 5 days off of lost time. So when they happen, they're usually relatively serious, and a lot of people would say, well, but that's 390 out of what number? I mean, what percentage? Does it really make any difference? If we go out in the world and we say, well, it's okay that we have 390 people injured running press brakes, when we have a better alternative, how is that really an acceptable number? And it's also interesting with when they happen. Notice 6 hours or more into shift, 230 out of the 390 happen. So as we get more and more fatigued during the day, we usually get a little more careless. So what are the 5 steps in implementing a robot? Well, we feel somewhat qualified to talk about this in that we've been doing this for customers for almost 35 years. And the number one thing that, well, we would put up here is that you must have consensus. And let me back up here a little bit. There we go. You must have company-wide support. And we think this is from the very top all the way down to anybody working on that shop floor that's going to be affected by this automation package. And probably even others in the facility. So get the employees directly affected, help them understand you're not doing this to replace them, you're doing this to supplement them, and that there's plenty of work. Our most successful installations are in some companies who've absolutely had 0 layoff. In fact, I can guarantee you 0 layoff because of automation. So, but the senior management staff also needs to be involved. Then reach a consensus of what success will be. So when you are installed, when this system is in and running, what will you see as being a reason why it was a good reason to do this? Just as important is a consensus of what a failure will be. And these items up here, your process is not in control, it doesn't meet the measurements you've set for success, the change is not supported by the organization. All of those things can be attacked and probably mitigated, but they have to be identified up front. It's very, very difficult. We walk into customers and there's, unfortunately, it's a little bit of human nature, but there always seems like there's a few people sitting in the back just kind of looking for a reason why this isn't going to work. Now, these same people may have a reason for nothing that's change is going to work, unfortunately. But you have to be sure that you've talked about these things. Then prepare a budget. Once you understand what you want this to do, what the success is going to mean, what potential failure would look like, now you can sit down and say, well, what's going to be the cost savings? Nothing. It's our experience that every once in a while someone will say, well, we're just going to buy a robot. And well, why? Well, we just think we need to. Well, that's not a reason in itself. You've got to have something that you expect out of making that investment. But what costs will be eliminated? How much of the increased production can you sell? What's the estimated cost of the robotic solution? And if you can't estimate that, there are multiple integrators such as Aceta that can help you do that. And what additional costs will be incurred if you install a robot? Is there anything? Maybe you need to make your blank more consistent, so you have to change your process up front so that you can automate the process. What's really important about that slide is when you have that budget and you invite Aceta or any of our competitors in, be sure and be willing to share that information with those people. Because it does you absolutely no good for them to gather all the data, go home, prepare a nice proposal, come back, it says 250,000 and you were thinking it was 50. And all of a sudden you've just wasted their time. The analogy I use is if you were going to go buy a new house, you don't drive to the local real estate agent and just say, just start showing me houses and maybe I'll find one that's in my budget. It's the first thing you start talking about. What kind of a home can you afford? Or what are you looking for? But once you have that information, then there's a bunch of technical data that needs to be gathered and non-technical. The whole world's working in 3D. If you have 3D models, be willing to share them. You'll probably have, if you're in the machining business, you probably have 2D part prints that have tolerances and maybe material information. There's probably work definition. There's, in many cases, fixturing and work holding that has been designed, and you can share that. And then pictures and videos are almost priceless. And if you can't do all of this, do that last one for sure. Because an integrator that's had some experience can pretty quickly tell you whether you're looking at an application. Then the next thing they're going to ask you are these items down below. What is your need? Some people mix up tack time with process time. They're not the same thing at all. Tack time means how many do I need to fulfill the market? Process time is how long does it take to do that operation? So sometimes you can way overproduce, sometimes you can't keep up with the tack time, but they are two different things. Annual volumes, what's available today and what could you sell, and which is closely related to tack time, and is the market for this product elastic or inelastic? If you could reduce the cost of this product, could you sell 10% more? Maybe. So then we have a spreadsheet, and we'd be happy to provide that if you were interested. But this helps you analyze your return on investment. So all the yellow boxes you fill in. So in that first column there under manual operation, what's your hourly rate? What are you paying that operator with all the fringe and all the rest? How many shifts how many hours do they work? How many shifts a day? How many days? How many weeks a year, etc.? On the other column, it's the same data, except the operator's only going to have to be there 10% of the time. So you get a huge savings right there, $180,000 a year in labor savings. Then will there be material handling that needs to be brought into the cell? Will somebody need to bring material to these people? What's the maintenance cost? In this case, we find commonly that maintenance goes down because the machine tools that are being displayed here and several other brands, if you want a consistent operation, just run them. They're much better if you just put the part in as soon as the next cycle is done. So, but if you walk into a lot of facilities and they run them and then there's a break, or the operator has to go get material, or they have to go get tools, or they have to do this or that, not things that they may necessarily want to do, we require them, and now the machine has a chance to cool off, and it gets spindle droop, and you start having tolerance issues, and all of those kinds of things are somewhat mitigated with automation, because when that spindle stops, the robot's there, and it's going to load and unload the part. So you run on down here, what's the annual savings, what's the annual labor savings, proposed automation. This is just all fictitious, $350,000. But notice, just slightly over 2 years. And what's really interesting is, look at the cash flow that this system throws off. So, of course, in the first year or so, you have that large investment. So it's below the line. The next year, almost half of it goes away. And then all of a sudden, you're almost, in year 2, you're almost, you have very little bit left to pay off. And now that you start generating cash. And look at the end of 5 years, this $350,000 investment has thrown off $665,000 worth of cash. Because you get those cost savings for the remainder of the life of that system. And there aren't many investments that you can go do that will throw off that kind of cash. So successful robot users, they're 110% committed. They have decided we are going to do this, and we're going to be successful at it, and we're going to face the hurdles, and we're going to get over those hurdles, and we're going to, and because it's going to be good for us to learn. If it's not, at least you've tried. It's one of the very interesting things. I have customers, oh, I don't know. I just don't know if it's good for me or not. How are they going to know if they don't try? So you be engaged, be part of the process, be there for the runoff, incentivize the workers, have them become part of the program. Find, customers that really buy in, see even better results 6 months after installation. We had a customer recently bought a welding system. They sent their operators to a week in advance. We taught them how to program, and when it came time to run off for their bosses, they told us, stand back guys, we're going to run this system for our boss. And quite frankly, their management team was blown away. They couldn't believe after a week that these guys were so confident that they were more than comfortable running this system for their management team and stuff. So they were active participants. That system, by the way, has been installed for about a year. I think we have got literally 0 phone calls about that system because those people were engaged and they came and they learned about the system. So how many signs will you ignore? Scrap parts, obviously you can't ship them. You'd love to have increased production, but you can't find the workers. China is buying more robots than any other country. This is absolutely true. Foxconn, I don't know if that's a name that means anything to anybody, but they are a major supplier to many of the electronics companies, and they build assemblies. They build a thing called the iPhone. And they installed 40,000 robots in 1 year. We have no one in the United States or North America that's ever done anything like that. Maybe 400, even in automotive plants, maybe a couple thousand. But your competition is buying robots. People, every day, we have people that are buying them from us, our competitors. Notice, in 2016, we sold 35,000 robots in North America. I told the group yesterday, I've been doing this for almost 35 years. I remember sitting around with a group of industry leaders, and we kind of came to the conclusion, if we ever got to 5,000, we had reached nirvana. We would never need to sell more robots than that in a year. Well, now we're at 35,000 and going up. In fact, the market is projected to be 100,000 robots by 2025. I think we'll probably beat that. The only reason we won't is because there aren't enough people to implement the robots. So I'll just put a pitch in. If you are interested in this technology and you kind of feel like you're in a kind of a no-win opportunity in your current career, there's a huge opportunity in the robotics business, and anyone can learn to do this. So what are you going to do? You going to continue to lean against your plow and hope the old nag pulls it through the field, or are you going to buy an automated machine? Agriculture in 1900, 50% of the people in North America were engaged in agriculture. Today, it's about 2% of the population. And our production, I think the last I saw it was like 2,400% more than 1990. And now, of course, we have more people, right? But still, if you think about it, and that's a small machine. If you're not from the part of the world where fields are, a mile long and stuff, these people can now, one guy can plant a quarter of a section in one day with no problem whatsoever. So which way are you going to go? Any questions? Wow. That must have been the world's great. Oh, thank you very much.
So what is the lifespan for your robotics?
What's the lifespan of a robot? I'll just answer to that. We have robots running today that are 20 years old. Not many, okay? Most of the time I answer that question with, about 10 years in most applications. Technical obsolescence is probably closer to 7. So if you had a robot and it was out there on your shop floor and a whole new job came around and you really didn't need that production that it was originally used on and you wanted to redeploy it, if it was 7 or more years old, you'd probably want to seriously consider replacing it. But I will tell you, we have 20-plus-year-old robots out there running. So, any other questions? Wow. All right. Oh, yes, sir. I'm sorry? You know, it drops off pretty steep. If you were to buy a robot tomorrow and apply it, the question was about resale for robots, and apply it and run it for a year or two, you know, it's all over the map. If you found somebody that had, you know, 2 of those and they knew exactly what they were and they knew how to apply them, you might get at least 50% of the original. Commonly, I would tell you 30%. I just knee-jerk reaction and stuff. It's kind of about where the market is. So, however, the cost of robots are coming down. So as volume goes up, like anything else, the cost of the actual product and the capability is so much different. I mean, what you can buy today compared to what you could even buy 5 years ago is a pretty dramatic difference and stuff. Any other questions? Yes, sir. Can anyone learn?
Why is that so easy?
Great question. So the question was, can anyone learn how to implement a robot? It's interesting you would ask that question. Just yesterday, I wrote a potential customer a letter. And the industry kind of says to integrators and builders of robots, they say, you know, I want a robot that one of my inexperienced operators can drag up in front of a machine, and in a few hours max, I can make it load and unload that machine. And the analogy I called out is, I said, well, if you found somebody who had never sat down in front of a computer, they didn't know the screen from the keyboard, and you said to them, sit down at this computer and just do a little email, would you? How long would it take them before they even got into email? Hours? Maybe days? Who knows, right? So with 1 day of just kind of hands-on instruction, this guy who doesn't program robots, hasn't for 20 years, could teach you to program a robot. And the thing, if you know anything about CNC machines, today it's no longer true, but in the past, you used to have to be pretty good at math and trig, right, to figure out the paths. Today, of course, we bring the model in, and the CAM systems find the path for us automatically and write the code and all the rest of that. So if you can get some basic routines into your machine, which are, you know, on a machine load application, move the part from outside the machine in, remove, and put the new blank part in and come out. Just that simple program. You can probably take that program and in the matter of minutes, use that same program for another part. Because there's only a few points that are really changing. Out here can be the same, in front of the spindle can be basically the same. It's the point where you load the spindle and the point where you take the part out of the spindle. That's the only things that really change. So you just copy it over to a new name and touch up the points. So, did that answer your question? Well, if you'd like, you see this young man working on his phone, he'll take you down to the FANUC booth and he'll show you how to program a robot in about 15 minutes. Yep. So, Any other questions? All right, well, thank you for your time.